Alright, number 2, question 2, about these. It's been a while between question 1 and 2, but hopefully you've had a go at some of these stoichiometry problems, and hopefully you get an idea about what's going on. But I thought I'd better do the examples that I've given you anyway, and just so you don't complain to say they didn't show you enough. Well, here it is. Apologies about the shadow here, can't be helped. Lights above, iPad's in the way. Anyway, let's read through the problem. Pure copper is reduced from copper oxide, which is CO, by heating it to a very high temperature. What mass of copper oxide would be needed to produce 4 kilograms of pure copper if the equation for this reaction or this reduction is this one here? So let's look at it. This is part 1. Obviously this is a stoichiometry problem and it works in 4 parts. Part 1, as you said, is writing the equation, and we've got that written down here. Part 2 is looking at number of moles. Before I get into this, with my equation, I tend to like to write down underneath my species here what I've got of them. Now it says I've got what mass of copper oxide, so I'll put a question mark next to my copper oxide, or underneath that, would be needed to produce 4 kilograms of pure copper. So I'll write down 4 kilograms there and a question mark there. So part 2, step 2, calculate moles. We want number of moles equals mole mass over molar mass. We're given our mass of copper, which is 4 kilograms. So therefore, Cu equals 4,000, because we're going to convert it into grams. For moles, it always needs to be in grams. Divided by the molar mass, which we get from our periodic table, and that is 63.5. We work this out in our calculator. 4,000 divided by 63.5 equals 62.99. 62.99 mole. And that is of copper. So that's step 2 done. Step 3 is our ratio question, where we know the number of moles of this. What's our number of moles of this going to be? So our number of moles of copper is known, divided by the coefficient, which is 2, equals number of moles of copper oxide divided by its coefficient of 2. Because our coefficients here are both 2, so it's both over 2. This means that the number of moles of copper will be equal to the number of moles of copper oxide, because it's both dividing by 2, which will be equal to 62.99 mole. Because our number of moles of copper is this, so therefore our number of moles of copper oxide will also be that. Basically because it's the same ratio. It's 2 to 2. If you've got 2 of these, you get 2 of those. If you've got 1 of those, you get 1 of those. If you've got 62.99 of these, you'll have 62.99 of those. And that's the ratio, setting out like this. Step 4 is where we do the question. Do what I asked you to do. And what is it asking us to do? We want to know the mass of copper oxide. So we want to know the mass of copper oxide. This is going to be equal to the number of moles multiplied by the molar mass. Okay, basically rearranging this equation here. So N equals M over Mr. Therefore mass equals number of moles times molar mass. So this is equal to our number of moles, 62.99, multiplied by our molar mass of copper oxide, which is 63.5 plus 16, copper, oxygen. Banging this in a calculator. Where are we? Calculator. Can't say that word properly. Times bracket 63.5 plus 16 equals 5,707.70. 5,007.7 grams. This is equal to 5.01 kilograms of copper oxide. I changed it to kilograms just because it's a bit of a nicer number, it's a smaller number, so therefore that's why I do that. So that's stoichiometry, using our mass of copper to work out our mass of copper oxide. Finding out the number of moles first, doing a quick ratio, and then doing what the question asks to do and find out the mass of copper oxide. Question 2, done. Okay, question 3. Now question 3 is a bit more of a fun one. It's to do with, can't do this question actually. Let me change this question a little bit, just so we can do it. If I say that sodium hydroxide has a concentration of exactly this much of 1 molar. Alright, because we need to have volume and concentration. Anyway, let's have a look at read of this question. It's to do with volumes and concentrations. So it's basically a titration question. And we'll go and talk about titrations in a second. You've already done one, but we'll talk about it in more detail a little bit later. Anyway, 25 mils of an unknown concentration of hydrochloric acid was neutralized with exactly 35.25 mils of sodium hydroxide of a concentration of 1 molar. Calculate the concentration of hydrochloric acid. How are we going to do this? It's exactly the same as other stoichiometry ones, but instead we're doing with concentrations. Still the same steps. So 1, we need an equation. We have hydrochloric acid, HCl, plus sodium hydroxide, NaOH. This is an acid, this is a base. It's going to form a salt, which is going to be NaCl, plus water, H2O. There is our reaction. This is going to be aqueous, this is going to be aqueous, this is going to be aqueous, this is going to be liquid. Okay, states in there as well. Always nice to put your states in because otherwise you lose marks. Or you lose a mark, I should say, not marks. Underneath these things, I'm going to put down what I know. And I've got 25 mils of hydrochloric acid, 25 mil. I've got 35.25 sodium hydroxide. And I got 1 molar of sodium hydroxide as well. So I've got this underneath there. Let's have a look at what I need to do. I need to work out 2 means mole. What can I work out the mole of? I've got a volume and I've got a concentration here. So I can work out number of moles of sodium hydroxide by doing C equals N over V, so therefore N equals C times V. So therefore, my concentration is 1 molar. My volume is not 35 because it has to be in litres, 0.03525. So therefore my number of moles is 0.03525 mole. That's the number of moles of sodium hydroxide. And there you have step 2 done. Because I have a concentration and I have a volume. Might as well put mils here as well, just so we know. Step 3 is ratio. Again, what we know our sodium hydroxide. We've got our number of moles. We want to find out hydrochloric acid. So we're going to have NaOH over 1, which is number of moles, equals number of moles of HCl over 1. So therefore, my number of moles of NaOH is equal to my number of moles of HCl, which is equal to 0.03525 mole. Okay, once again, it's a 1-to-1 ratio. You're very lucky, you got a lot of 1-to-1 ratios here. Hopefully this fourth question is not 1-to-1, so I can explain how that works. Anyway, do what the question asks you to do. We want to find the concentration. So concentration, as you know, equals number of moles over volume. You know your number of moles of hydrochloric acid, which is HCl, which is this. So equals number of moles 0.03525 divided by moles, our volume of hydrochloric acid, 25 mils is 0.025, and that equals, trusty calculator as well, 0.03525 divided by 0.025, 1.41 molar. HCl. So there you have it again. And that's our concentration of HCl. Once again, 1, start off with the equation. 2, find out the number of moles of the stuff you can. If you've got grams, use that. If you've got concentration and volume, use that. 3, do a ratio. 4, put in and do what the question asked you to. Should write do it here. Okay, find out what the question asked you to do. And that was calculate the concentration of hydrochloric acid. This is a simple titration question. These are the ones you're going to be doing a lot of. Okay? Because your titer is going to be neutralizing it. When you do a titration, what you're doing is a neutralization reaction 9 times out of 10. Anyway, if you have any questions on this, email me, so on and so forth.